Hi everyone. Let's now create the second module for Kafka, which is kafkaadmin. In this lecture and in the next lecture, you will implement a kafkaadmin module using the admin client class from Apache Kafka library, which is the administrative client for Kafka. You will create Kafka topics in this module and also will check if the topics are created and schema server is running prior to running microservices. This will be required because when you run all components in a single Docker Compose file, if Kafka or schema registry or any other dependencies are not running, your application will fail at startup and will not continue to work as expected. So to make your services more resilient, you will need to add some checks prior to running services. And in this module, you will implement these checks. Note that in the coming lectures, you will be adding more checks on the Docker Compose file, apart from these programmatic checks, so that your services will be more and more resilient. We will start by adding the dependencies first. We need to add upconfig data from our local dependencies. And also, we need a new dependency, Spring Kafka. So let's go and find Spring Kafka dependency in Maven repository and add it with version in the main.xml file, and finally use it without version in the kafkaadmin module. In this module, we will target to create Kafka topics automatically, and also we will write a logic to check if the topics are created, so that we can use this module to be sure topics are created and ready to be used by the application. First, you will use Spring AOP here to create a retry template, which will help you to retry for the operations, creation of topics, and checking existence of topics. Here you need retry logic because when you start everything together, including Kafka cluster and your services, you might need to wait until Kafka cluster healthy and ready to create topics and returning list of topics. Spring AOP and specifically Spring retry template is a perfect candidate to use in this scenario. I might create the retry template and the configuration in this module, but we might actually need this retry logic from the other modules and services too. How can you make this logic reusable? Again, creating a new module. So let's go and create a module called common config and add dependencies upconfig data, Spring retry, Spring boot, and Spring IOP, which are the necessary dependencies in this module. For Spring retry, let's go and find it from Maven repository and use the current latest one, which is 130. Note that Spring IOP is required to be able to use Spring retry in our application. And we use this Spring Boot version for this dependency, so we can skip the version definition in main.xml file. Let's then add a class called retryconfig here. We will first create a package com microservices demo common config, and then create a bean to create a retry template. To create this bean, we need some configuration data. So let's first go and create retryconfig data class in the upconfig data module. Here we will create the config properties we need: initial interval, max interval, and multiplier for exponential backup policy, and max attempts for a simple retry policy. So we will define initial interval and max interval as long, multiplier as double, max attempts as integer, and sleep time millisecond as long. We also need to define these config variables in the application YAML file. So let's initialize these variables with the corresponding values with a prefix retry config. After adding configuration variables, let's now complete the retry config configuration bean. We will first inject retry config data, and then create a method called retry template, which will return retry template object. We will first create a new retry template object here. And before returning this, we will add an exponential backoff policy by creating it with initial interval, max interval, and multiplier from config data. Then we also add a simple retry policy to retry template by creating it with the max attempts property from config data. Then we will return the retry template from this method. Here we also need some Kafka configuration to be used by kafkaadmin module. So let's add Kafka config data class in appconfig data and start adding Kafka properties. Bootstrap servers, schema registry key and value, topic name, topic names to create, number of partitions, and replication factor. Then we will create a Kafka config prefix in application YAML file, and then initialize the properties of Kafka config. As you can see for Bootstrap servers, we use the hostname and port numbers from Docker Compose file we created in the previous lectures. And again for schema registry URL, we set localhost 8081, which is also defined in the Docker Compose file of Kafka cluster. And for topic name, we just set Twitter topic. For topic names to create, we only add Twitter topic for now. That means we want to create this topic programmatically at runtime. And then for number of partitions and replication factor, we set as 3. Let's fix this typo and indentation here. Now we can return to kafkaadmin module and add common config dependency. Then we will create a package com microservices demo kafkaadmin config. And create a new class called kafkaadmin config, which will be a configuration class. So we will annotate it with configuration annotation. We will also use enable retry annotation in this class to enable retry logic for our application. In this configuration class, we will define a feed for Kafka config data and inject it using constructor injection. Then we will create a new bean with a method called admin client to create a Kafka admin client using the Bootstrap service configuration data. We will use this admin client to create and list the Kafka topics programmatically. Finally, let's create a package here called clients and create a class called kafkaadmin client. and mark it as component. We will then create a log variable first, and then inject the required objects using constructor injection. We will inject Kafka config data, retry config data, admin clients, and retry template objects. Great, good job so far. We will continue implementing Kafka admin client in the next lecture.